Hi, this tutorial covers Bayes rule. So let's take a look at an example where it'll be useful to use Bayes rule. So an online retailer allows you to choose from two shipping services. These are fictional, but we'll call them Speedy and Quick, both who offer overnight delivery of parcels. Suppose an important parcel is ordered and it is extremely important that it is received by 10 a.m. the next morning. Suppose Speedy is used 70% of the time. And then Quick fails to meet the 10 a.m. deadline 10% of the time, while Speedy delivers late 8% of the time. So suppose a person received a package late. What is the probability that the late package was delivered by Speedy? Okay, so we're trying to figure out the probability that the late package was delivered by Speedy. So that's the question, so keep that question in mind as we go through this. Okay, so let's first of all define the following events. So let's let event S be the event that the customer chooses Speedy, K the event that the customer chooses Quick, L the event that the package was late, and so let's use those letters to denote the probabilities that we're given there. Okay, so let's start with the 70%. So it says suppose Speedy is used 70% of the time. Okay, so all that probability is that's just the probability of S. So that's 0.7. Okay, the next one, Quick fails to meet the 10 a.m. deadline 10% of the time. So that's the probability of late given Quick. So that equals 0.1. Okay, and then while Speedy delivers late 8% of the time. So that's going to be the probability of late given Speedy is 0.08. Okay, now let's also notate the probability that we're trying to find. Okay, so remember that the question we're trying to answer is what is the probability that a late package was delivered by Speedy? So the question we're trying to answer is what's the probability of Speedy given late? Okay, so we're given conditional probabilities, but the conditional probabilities that we're given are where the given conditions are the service, the delivery service. Okay, so we know late given Quick and late given Speedy, but what we're trying to figure out is kind of the conditional probability turned around. So if you're faced with this situation, Bayes' rule is the rule you want to use. So Bayes' rule is a way to turn around a conditional probability, sometimes leading to surprising results. Okay, now Bayes' rule, it's the formula is pretty large. We're going to kind of look at, we're going to kind of break it down using a tree diagram in a minute. But so if A and B are non-overlapping events with the probability of A plus the probability of B equaling 1, then for any event E, the probability of A given E is equal to the probability of E given A times the probability of A over the probability of E given A times the probability of A plus the probability of E given B times the probability of B. Okay, so you notice that the probability we're looking for here is A given E, but anything in the formula, your events are reversed here. It's always the E comes first in the conditional probabilities. Okay, so now what we're going to do, like I said, is make a tree diagram and see if we can figure out where this big formula comes from. Okay, so with our tree diagram, we're going to start with basically the customer's choice of which service to take. So either Speedy or Quick. And we knew that the probability of S, the probability of Speedy was 0.7. So we're going to put that there. And the probability of Quick then has to be 0.3 because those are the only two outcomes. So the part of the Bayes rule that says non-overlapping events with the probability of A plus the probability of B equaling 1, that's what that condition is met here because these two add to 1 and a customer can't choose both delivery services for the same package. That wouldn't make any sense. So, so they are non-overlapping there. Okay, now the next level of the tree diagram is either going to be late or not late. Okay, so I'm going to notate that as L prime, and then late or not late. Okay, now we can fill in the conditional probabilities that we were given. So late given Speedy, that goes here. That's 0.08. It said 8% of Speedy's packages are late. So that means 92% of them are on time. We know that 10% of Quick's packages were late, so that means 90% of Quick's packages are on time or not late. Okay, so again, we're trying to figure out the probability of Speedy given late. Okay, so this is a conditional probability. Okay, so the first thing we need, generally when we find a conditional probability, is the probability of late. Okay, so the probability of a package being late, there are really two different outcomes. There's this outcome, speedy and late, and this outcome, quick and late. Okay, so what we need to do is determine each of those probabilities. So this would be the probability of speeding and late. So the probability of S times the probability of late given S. So that's what that is. And then it's plus the probability of quick and late. So 0.3 times 0.1. Okay, so this is the probability of quick times the probability of late given quick. Okay, then on the top of the fraction, we need the probability of speedy and late. Well, that's the same as this probability here. So this is 0.7 times 0.08. Okay, so that's actually going to match our formula pretty well here. Okay, so the top is 0.7 times 0.8. Okay, so the 0.7 is the probability of A here, the probability of S. The 0.08 is the probability of E given A, or the probability of late given speedy. Now all of this matches the bottom here. So this was just the probability of late in general. So what this is going to end up being is the probability of E in general. Okay, so you always have to add up two different outcomes to get that. Okay, so let's finally actually calculate this probability. So I'll do the numerator first, 0.07 times 0.08, so that's 0.056 over, and then I'll do all of the denominator in one step. So 0.7 times 0.08 plus 0.3 times 0.1, and that's 0.086. 0.086. Okay, and then to divide those two, okay, we end up with about 65%. So that means that if you knew the package was late, there was a 65% chance that it was speedy. So even though speedy only produces 8% late packages, Quick produces 10%, there's actually a higher probability of a late package being from speedy than from Quick. And the reason is because more people choose speedy. Okay, so when we talked about Bayes' rule and sometimes leading to surprising results, this would be your surprising result, that more late packages, there's a better probability of a late package being from speedy than from Quick, even though speedy's on time more often. All right, so that was a calculation using Bayes' rule with the aid of a tree diagram. So that's been your tutorial on Bayes' rule. Thanks for watching.